Okay, take two. Unleashing synergies, building bridges. We've just heard that we'll be speaking about standards, and specifically we'll be speaking about two things, OPC UA and AutomationML, which have been around for a long time. I could almost say that they are in the adult phase, and we have a combination of OPC UA and AutomationML, which has been around for 10 years now, as we've just heard. What this means is that standards themselves also have their niches, their use cases, but 10 years ago it was considered that it might make sense to combine things to work together, and not to duplicate the things that the other can do well. And this is what we're going to look at today. I would like to begin by looking at domain models. If we have a look at these little figures here on the slide, you can see that everybody has their own domain model in their own head. Perhaps one of the people thinking about construction, the other from e-planning, the other from software development, control technology, virtual commissioning. There are a number of different domain models which all of these little people have in their heads, and all of them are justified. Therefore, they start to think about things, and if you bring a number of different people together and say we would like to define one single model, then it's possible that they'll be thinking about exactly the same model. However, if you take this to the next level, and this actually happened a few years ago, and one of the things that characterizes our industry is that there are standards which can apply to this. There are two different factions in the example. We've got OPC UA and also AutomationML. AutomationML comes into play in engineering, which is where we speak about data exchange in engineering, which is very important for all the engineering information. At OPC UA, this is an information hub. There are also information models, but there are models which are used for commissioning. You could say domain models, very good. There are several of them. Why is this interesting? Why doesn't everybody just create their own model? And the answer to this is quite straightforward. If somebody has already conceived this, has come up with it, it perhaps makes sense to reuse it. Take football, for example. I think this is something which everybody understands. If somebody has run down the wing and crossed the ball, it's not, you wouldn't say that you can't do this again. There are training exercises for this. There is a specific sequence as to how you run with the ball. There are specified positions on the pitch. Therefore, there's a lot of knowledge that a lot of people who are quite smart have already come up with. And this is what characterizes domain models at the end of the day. They allow you to enlarge a success, so something which somebody has done incorrectly in the past, you can avoid making the same mistake in future. And you can do the things which have gone well, rather than having to reinvent the wheel. So we know two domain models. One is very engineering heavy, the other one from operations, where you've got a lot of advocates, a lot of members who define specific things. Now, 10 years ago, not at Hannover Messe, but this was actually at the SPS IPC Drives Fair in 2013, the two organizations came together and they are behind the standards project. They said, we don't want to do this individually, we'd like to cooperate. We don't want to have to reinvent the wheel. If one group has written a program for a model, we don't want to have to completely start from scratch for another one, but we can simply transfer the information from one robot to the next. This is how the cooperation project started. Back then, this was in 2014, a number of different companies were involved. These companies said this would make sense for us, we'll use both standards, it would be quite good if we could use them in combination. Now, 10 years isn't that long in the life of standards. There are some results which have come about. We have the companion specification, which means an information model for OPC UA. Here you have a description of how AutomationML can be used in the field of OPC UA. There encompasses mapping rules, so you can translate one to the other. There are also standard libraries which are written into it, which this has been around since 2016. Advanced mapping rules can be found in the specification version 15.0.2. there is also the well, there's a best practice recommendation called data RICA concept. Now, because we said, okay, it's very good, this is paper, you can read it, you can re-implement it, but ultimately everybody wants to use it, which means that post-implementation, subsequent implementation is not just about source implementation as SXAT, maybe you'll know XML to translate this to XML, for both mapping directions. So from AutomationML to OPC UA and from OPC UA back to AutomationML. And these mapping rules, these implemented mapping rules, can be used if you have use cases. I'd quickly like to speak about what these use cases are. If you come from engineering and you have an information model, now you go into operations, then not all of the information that you have flashed onto this are unimportant, rather some of the information can also be used in operations. For example, which machines you've installed, how the machines are connected to one another, what type of information they're able to provide, type of service intervals, etc. to the manufacturer. These are all set during engineering, and you can also integrate these into operations. You can do it manually, or the generation of the OPC UA information models can be translated into AutomationML, so commissioning, re-engineering, maintenance and service, by continuing to enhance these models over its life cycle. Now, that was point number one. Point number two, you've got OPC UA information models. If you'll be familiar with the list of different companion specifications, you will know that lots of different experts had to come together to consider how devices need to be described, how robots need to be described, how test and measuring devices need to be described. These are not only bits of information which are relevant in operation, they also contain useful information that can be used in engineering. Static data, which are required in engineering, can be taken from the OPC UA information model as a library and integrated into the AutomationML model. One thing I'd also like to point out, I haven't emphasized this explicitly, but the objective is not to take entire models and move them from one world to the other, but only the one that makes sense, because we don't want to take everything which is in engineering and put it in engineering, because we don't need all of the information. There are certain bits of information which are important and which are relevant, and when it comes to these bits of information, it does make sense to put these in the other world as well. Another case where you can really combine the parts well is the point that configuration in OPC UA configuration information might be known in AutomationML. If you know what the structure is, if you know which hubs are relevant for you, then it's possible to save this in engineering and use it in order to pre-configure the connections. This is the third case. Now I'd like to have a look at this. I've got some practical examples which I would like to present to you. Things which do make sense in this combination. If you're in operations, you've got different devices and connections. It's not like somebody plugging in a wire on a construction site. Everything's been planned. You've got a specific device configuration. All the control technology is involved, and all of this information is in the AutomationML model. There is an application recommendation, which is called Automation Project Configuration. This what you can do is say, the part which is relevant for me, I'll move this to the other model, and then you've got AML2 and if you've got these mapping rules which have been implemented, you can move one thing to the other. That's point one. Point two, in OPC UA, the OPC UA context, you've got companion specification robotics, And it doesn't just tell you which signals are provided, it tells you what type of robot it is, what type of robot, which parameters the robot offers. And this is all information which you also have in your engineering model. Therefore, again, you don't need to completely redesign the domain model. You can simply take the companion specification model, put it in AutomationML and use it. And this re-engineering is the point where what you'd have to say is that we don't want to have to completely recreate this information. If in one organization you've got a group which has defined everything, it doesn't make sense for the other organization to set up a working group and redo everything from the beginning. You can simply transfer the information. Another thing to point out, if you're not a large multinational company or you're a smaller company, maybe you'll get one requirement for one standard, one for the next standard. Perhaps there's a proprietary tool which needs to be supported, and you end up implementing one interface after the other, one model after the other, and this does not make sense. But at the point in time and the position you're in, there's nothing you can do to change it. Everything with the standards, to make sure that the standards make sense, time and again, you need to try and recap everything that you have. So there's no either or. You don't need to decide whether you only use one or use the other. If there's something good for one of them, then you can reuse it. Now, there's not just AutomationML and OPC UA standards. It's important to point this out. These are just two examples where we've had cooperation for around 10 years. Things which are laid down in specifications to tell you how you can map from one to the other. There are other standards which make sense in the industrial sector, including the asset administration shell, the FMI, the functional mockup interface. And again, here, it's possible to get simulation models in FMI and use them in AutomationML models, but also in AAS models. Therefore, the specifications do exist. You simply have to get out there and do them and apply the standards. It's not just as if you can only use one of them or only use the other. You can use several of them. There were research projects underway, including the Diamond project, which is taking place of the 35A research program, not just demonstrators, but also software interfaces which apply this principle. There are device manufacturers like Festo, which also takes the same approach. You don't decide for one standard over the other, but that you combine the standards. If anybody is interested in coming and having a look at this, you can come over to Hall 9 to booth F30 at the OPC Foundation, and here you can find a sub-booth for AutomationML and the OPC UA Foundation, where you can have a closer look at some of these practical examples. And if you have time, and we'll be here for a few days, we'd be delighted if you would come over and see us and have a look at a live demo. Thank you very much.